Welcome to the Explainer. Today, we're taking a look under the hood at the engine that powers modern big data, Apache Spark. We're going to break down what it is, how it works, and why it's pretty much become the go-to for making sense of absolutely massive data sets.
You know the feeling, right? You click on some giant file and your laptop just grinds to a halt. The fan starts screaming, the mouse won't move, and you just sit there. That exact moment of helplessness, that's the big data problem in a nutshell. And that problem, the one where your data is just too big or the math is too slow for a single machine, that is exactly why Apache Spark exists. It's not just another program, it's a fundamentally different way to think about handling data. So let's get real for a second. When do you actually hit that wall? You know, the moment you realize your trusty old tools just aren't going to cut it anymore. Well, it almost always comes down to two big scenarios. So you've either hit the size wall or the speed wall. The size wall is obvious. Your data file is just physically too large to fit in your computer's memory. We're not talking about a big Excel file. We're talking gigabytes, terabytes, petabytes of data. Then there's the speed wall. Maybe the data fits, but the analysis you need to run takes hours, or worse, days. This is exactly where things like Excel or even the popular Python library pandas just hit their limit. All right, so when your data problems get this big, you need smarter tools. And this is where we meet our hero for today, Apache Spark. But what is it really? Okay, there are two magic words in that definition, unified and distributed. Distributed is the big one. It means Spark doesn't try to solve a huge problem on one computer. Instead, it acts like a general, commanding a whole army of computers, a cluster, to tackle the problem together. And unified means it's not just a one-trick pony. See, Spark is a whole toolkit. You've got Spark Core, that's the heart of the engine. But then built on top of that, you have all these other powerful components. There's Spark SQL, which lets you talk to your data using a language you probably already know. Spark Streaming for handling data that's pouring in live in real time. MLlib for doing heavy-duty machine learning. And even GraphX for figuring out complex relationships. It's the whole shebang. So this all sounds amazing, right? But how does it actually work? How does Spark coordinate this army of computers to get things done so fast? Well, the secret isn't just about having more power. It's about having a much, much smarter plan. Think of it like this. You're the CEO. You write down the high-level goal in your code. Spark has something called a driver, which acts as your project manager. It looks at your goal and breaks it down into a bunch of smaller, bite-sized tasks. Then it hands those tasks out to the executors. Those are all the worker machines in your cluster. They all go off and do their little piece of the job at the same time. Once they're done, the driver collects all their work, puts it together, and hands you the final result. Simple, right?
Now this is Spark's real secret weapon. It's called lazy execution. Most tools, like the one on the left, are eager. You tell them to do something, and they do it. Immediately. Step 1, run. Step 2, run. Step 3, run. Spark is lazy. You tell it to do a bunch of things, filter this data, combine it with that, sort it, and it just nods and says, got it. It writes it all down in a plan, but doesn't actually do anything yet.
And that plan has a pretty nerdy name. A Directed Acyclic Graph, or DAG. Just think of it as Spark's master blueprint, because Spark waits until the very end, until you say, okay, now give me the final answer. It gets to look at the entire list of instructions all at once. This lets it be incredibly smart. It can find shortcuts, combine steps, it optimizes the whole workflow before a single calculation is run. The bottom line is, Spark doesn't just work harder, it works smarter, and that saves a mind-blowing amount of time. Okay, enough theory. What does this actually look like when you're sitting at your keyboard? How do you, as a human, talk to this incredibly powerful engine? Well, believe it or not, it's actually pretty straightforward. Most of the time, you're working in a place you're already comfortable with, like a data science notebook. And you write code that looks and feels like you're just working with a normal file. So let's pretend we have a massive file with a bunch of product information we want to analyze. With just one simple command, Spark goes out, reads that massive file, and organizes it into this nice, clean table, what Spark calls a data frame. And look at it, it looks just like a spreadsheet. But the trick is, behind this simple view, that data might be scattered across dozens or even hundreds of computers, all ready to work in parallel. And here's where it gets even cooler. You don't have to be some kind of programming genius to use Spark. If you know SQL, and tons of data analysts do, you can just start asking questions in a language you already speak. And boom, this is where it all comes together. We write one simple SQL query, something a business analyst could write.
Behind the scenes, Spark turns that into its super optimized master plan, that DAG we were talking about. It runs that plan across the entire cluster of machines and then brings back this perfectly simple, clean answer. It's just so efficient.
Now, being able to do this stuff isn't just a neat party trick. It's what powers some of the most advanced, data-hungry applications that we all use every single day. Ever wonder how your favorite streaming service knows exactly what movie you want to watch next? That's probably a Spark-powered recommendation engine. Or when your bank texts you about a weird charge just seconds after it happens. That's Spark working in real time. From analyzing massive amounts of genetic data in healthcare to cleaning up messy raw data for businesses, Spark is the quiet, heavy-lifting engine behind so much of the modern world. And of course, once you've crunched the numbers, you can instantly turn those results into insights. Here's our simple product count data from before, now as a bar chart. And that's the magic of Spark, really. It takes you all the way from impossibly huge, messy data to a clear, simple picture you can actually use to make a decision.
So there you have it. That's Apache Spark, a seriously powerful engine that lets you solve problems at a massive scale, often using skills you already have. It really just leaves us with one final thought. As the amount of data in the world keeps growing like crazy, the question isn't if you'll face a data problem that's too big for your laptop, it's when. Is your toolkit going to be ready?